Good day to everybody. I am Ng Chee Yi. Today we are going to cover DC circuit analysis on this chapter 2. DC stands for direct current. In this subject we study DC circuit and AC circuit. Now in the beginning part we study DC circuit. This circuit we start with the circuit analysis, basic circuit analysis. Overall, a circuit is made of what? It's made of many elements connect together. An element is the basic building block of a circuit. An electric circuit is simply an interconnection of the element. So, circuit analysis is the process of determining voltage and current through the element circuit. There are two types of elements found in electric circuit: passive element and active element. So, then active element is what? Is actually electrical generally, and passive element is not able to generate energy. The passive element is what? Resistor, capacitor, inductor. The active element is what? Include generator, battery, and amplifier. After we study this one, we could cover what? Independent and dependent source. We cover 4 types of dependent source. First type is voltage control voltage source. Current control, second type is current control voltage source. And voltage control current source. And also current control current source. And so here. Independent is provided by circle. This voltage source dependent plus by DC voltage. Then this independent constant. This one constant. Then this one is independent circle with circle independent with the circle arrow up is what? Current source. Then dependent is what? Dependent is diamond. This one is voltage source. Then with the arrow one is diamond shape with dependent is the current source. Next we go to ideal and non-ideal voltage source. Ideal is mean perfect, no damage. Non-ideal is what? Is not the perfect one. Now we study voltage source. Voltage source ideal one, no impedance resistance. Then this one is then the voltage Vs. This voltage Vs can provide constant without drop. For here, if non-ideal, this one is ideal. For non-ideal one, we got what? We got a series resistance where we can cause a what? A small drop here. A small drop. Then we go to what? Ideal current source. Ideal, this is current source. Ideal one, no parallel. Perfect current source. With a constant what? Current source. Because of no loss here. Then non-ideal, non-perfect one. You got a what? This one. This one. This parallel resistance. We call a small drop in here. Okay? Next, we study source conversion in this chapter. Source conversion is what? Non-ideal voltage source, this one. Non-ideal voltage source convert to non-ideal current source. Convert. This one RS, same RS. convert here, convert to this one can convert back to here. With what? With using this relation, Vs equal to ISI, Ohm's law, and then Is equal to Vs over Is. Where Rs is here, Vs is here, then Is here, Rs here. With this formula, conversion. Then we will do what? Example. In this way, we will do example. This is example 2.1. Then we cover, after doing this one, we cover what? Circuit notation. Circuit. Means what? This one is what? Called node. This one node. This one node. Then this one also node. Then this one is what? Single. One single node. Single node. Single node. Same point. One single node. Whole thing. Single node. Same point. Then this one is what? This one is branch. Branch. This one is what? This one is called branch. This one is called branch. Then this one also branch. This one also branch. Okay? Branch. Then we study. Next we study Kirchhoff voltage law. Kirchhoff KVL. It means that sum of voltage around the loop equal to voltage. Sum of voltage drop across the loop same as what? Supply one. Okay, sum of voltage across is 0 at all times, or sum of around the loop is equal to potential drop around the closed loop. Like this one, E same as V1, same as E equal to V1 equals to V1 plus V2. E equals to V1 plus V2. KVL, Kirchhoff voltage law. Then Kirchhoff current law. Then we do the example. We will cover the example in detail in official lecture. Example 2.3, example 2.4. Then we go to Kirchhoff current law. KCL means that sum of current inside a closed loop means that in here is sum of current inside this single node. I1 go inside one minus this minus the I2 out plus the I3 inside minus I3, I4 go outside plus I4, I5 go inside minus. So hold this thing with inside direction minus outside positive plus positive direction. So sum up equal to 0. This one is Kirchhoff current law. This is covered by example 2.5. Then example 2.6 is in this figure. Then after that we will do example 2.7. Then we use what? 2.8 we do general procedure of circuit analysis based on what? KCL, DC circuit based on KCL and Kirchhoff current law and Kirchhoff voltage law. This is covered in example 2.8. Then what is meant by series DC circuit? This one branch, this series, here also series, here also series, one branch, single branch, one path A to B, one path, this is all series. Then this one series, total resistance add up. Then parallel DC circuit, parallel. This one two parallel, this one 4 parallel connection, parallel. Then we'll do the exercise later in full, like in official lecture on the current source, current divider rule, current divider circuit. Where this current I1 I1 is equals to this I1 plus I2, two parallel plus together, came out with I total. So given I total, we want to find I1. I1 equals to this I1 is here, is opposite branch R2 divided by total R1 plus R1 plus R2 times what? I total inside equals to I1. Then I2 same, equal to opposite branch I2 here, opposite branch R1. So it's R1 divided by R1 plus R2 total times I total equal to I2. Then I total equal to I1 plus I2. I total equal to I1 plus I2 from KCL. This one is current divider equation. Next, combination of series and parallel DC circuit. This one is series. The blue one is series. Then blue block and this blue block are parallel. This one R4 and R1 series. Then this block is 2 lasers series. Then these two are parallel. These two series. Then these are parallel. Then this yellow block are what? In series. Then we will do example on 2.9. Then 2.10, more complicated one. Then end of the lecture. Then we will cover tutorial. So we will do full lecture on this chapter. So this one is a brief introduction to the lecture we will cover in the first chapter. See you on the main class.